Thanks, Mike. Hi, my name is Vijay. Thanks for attending this session. So today I'm going over the eHarmony use case using the MongoDB Atlas for our messaging platform. So I'm pretty sure most of you guys know the eHarmony, and probably some of you guys are already using eHarmony. But for the benefit of the presentation, I'll go over the eHarmony and our use case first. So the eHarmony is an online relationship service provider. We provide our service to the people who is looking for a serious relationship and long-term relationship. So, sorry about that. So how do we do that? So basically, we collect the data from the user through our relationship questionnaire. Once we collect the data, we run our matching models. So we have various models, but the important models are compatibility and affinity. So let's talk about compatibility. So the compatibility basically looks for your values and your personality and profile, and then based on that, we generate the matches. And on top of that, we apply the self-selects. Self-selects are basically your age, distance range, and then some of the importance values like smoking preference, drinking preference, etc. Once we further filter the matches, then we apply the affinity model. Affinity model is basically a behavioral model. There are various aspects in that affinity model, but one of the important aspects is the communication. Basically, we look for inbound communication and outbound communication to find out the user personality to match with the other person. So we don't want to match two chatty people. At the same time, we don't want to match two inferiority complex people. So, so we optimize matching. We constantly evolve our models, and we optimize our matching towards a better experience. There are various parameters for the better experience. One of the important parameter is likability of the communication. Okay, so the more communication user has, the more good experience user will have. Then that leads to a good, the good long-term relationship. That's what we believe. So let's take a look at our product. So basically, we generate the matches every night through our batch jobs, and then user can see list of all their new matches or our existing communication matches. And then once they're interested in any of their match, they can further go ahead and look into their details, profile details. That's more like the details. And then if they're interested, they can start the communication. And the communication, right today, the old system, it's all eHarmony guided communication. I'm going to talk about it a little bit. And then finally, an activity feed. It's activity across all your matches. If somebody from your match updates the photo, uploads the photo, or updates the profile, or send the nudge, communication, whatever, that's all in the activity feed. That's our core product. So let's talk about our old guided communication system. eHarmony is there around for 17 years, right? When we started this product, users are not that comfortable or open to communicate to the other user through the dating site, right? So we have to give some hints. So we come up with this guided communication flow. So we were trying to guide the users through their communication flow to break their problem, right? So guided communication system is typically 18-step guided communication system where user sends the communication and they basically wait for the other person to respond back. Once you send the communication, you can't do anything but just sit down tight, right? So that's the problem. So it's very rigid. So it was working fine, but recently we started seeing the decline, right? And starting January 2016, the decline is pretty steep. So change is required. So the product team came up with the design goals, like the product redesign goals. So the goals are very simple. We want a simplified communication flow, no lockdowns, no steps, okay? Voluntary communication. User should freely communicate. If you want to send more than one message, go ahead and do it. Harass the other person until they respond. I'm just kidding. And then real-time messaging system like chat, right? The old system was like an email-based system. You send the email and then wait for however long you have to wait, right? And then there is no indication that the other person is read your message or ready to respond or whatnot. So we need to change that. We wanted to go with a real-time messaging system like chat. And extend the system to support the richer content type. So the old system was only supporting the text and some of our custom types like closed-ended questions or template questions or whatnot. But we wanted to go with like GIFs, videos, photos, and stickers, etc. And the support various custom business requirement. So we are in agile model, right? So the product always wants to push something, every day new thing, right? So with this rigid model, we can't change anything. Changes are like very hard to make, right? We want to break that. And then finally, improved user experience. So that's good. Let's take it the product mocks, right? So the very first one is a conversation screen where it's like an inbox, right? So across all your matches, you see the recent communication from the matches, and also you can see whether the message is read or unread, and the counts and everything. If you go with a particular history with a particular match, if you scroll up, you can see the communication with that particular person, and also you can initiate the communication. Either you can send a question and you can write a message. Actually, we introduced a few more things after these screenshots, and also we are working on more features. I'm going to discuss about that later. Okay, that's good. When product comes and says like, hey, we need to build this, right? And then first we need to evaluate what system we have, whether we can support this system, support these requirements with the existing system or not. I cannot say every time when product comes and asks me like, hey, can you support this? And I say like, oh, no, we need to redesign this system. We need like 6 months. No, we can't do that, right? Very few times you can do that. So you need to play your cards. So let's take a look at like our existing schema. So our old system was a monolithic web application backed by the Oracle database. It's a relational database. We have 20 tables. Half of the tables are to maintain the state of the communication, where basically whether the user send the communication, what state he is in, is he waiting for the response, or like, in the finite state mission, like what step he is in, right? And the rest of the half to basically save the actual messages, like icebreakers, closed-ended questions, or open-ended questions, must-have constants, just like all our internal message formats. Good. So when I say 20 tables, it's a highly normalized schema, right? So what's the problem? So now you have 20 tables, they have the referential integrity constraints, which means like more joins. More joins will kill your performance. So performance is one concern. Another concern, change to anything, even to add one column anywhere, right? So you need to touch so many components in the system, which means even my product comes and asks me like, hey, can you add this column or whatnot? They say like 1 month, 2 months. That's not acceptable in the agile world. So it's antiquated, large number of tables, complex joins, performance concerns, and rigid database models. Typically, everybody have this problem, whoever is using legacy system. So let's take a look at this. So eHarmony is using microservices architecture. We already migrated, 1 year ago, we already migrated 70% of our services to the microservices architecture. There were very few services pending. One of them, the very key thing is the communication. So we come up with this microservices architecture. If you take a look at very high level, we have Android and iOS. The clients directly goes to our API gateway. Our mobile web and web platforms, they go to the rendering layer, which is Node.js app stack, and then that goes through the API gateway. Then our COM aggregation service and COM services, they are on the service layer. They talk to store. So now let's talk a little bit about the chat system, right? Chat system. So I said before it was a mail type of communication where they can send a message and it goes to the service, and then that's where we store and then present it as a history to the other person. But in order to implement the chat kind of experience, we chose eJabberD, which is an XMPP implementation. So basically, they provide the WebSockets to the clients, so they can use the WebSockets to open the socket, and then they can do the duplex communication, not only sending the communication, but they instantly get the communication back. So now with the eJabberD layer, we use the webhooks to send the communication to the service, to store it in history, and also to filter, where basically we don't allow anybody to communicate with anybody, right? It's not like a open chart system. It is based on the match. We only allow matches to communicate each other, right? So those kind of filters are at the service layer. The communication service will take care of that. So for any microservices architecture, important thing is the store, right? The good thing is for your microservice, for your vertical, you can choose your tech stack and you can choose your store or whatnot, but be careful while choosing the correct store, because the store is the key for your services performance, okay? Okay, what are the store requirements? Okay, so we are moving away from a well-established Oracle SQL database to a NoSQL database. Okay, so these are the few requirements. Data consistency. Data consistency is very important. Let me tell you what I mean by consistency. I send a communication to the other person, right? I immediately refresh the screen. I want to see my data immediately, consistently. Okay, if you look at some inconsistent or eventual consistent database models where you send a communication, write goes to one node, right? When you ask for the same data again, maybe that request goes to a secondary node where the replication is behind, that node is behind in the replication, right? Then you don't see your update. So consistency is very important for our user experience. There is no compromise in it. And when it comes to CAP theorem, you can only pick only two, consistency or availability. Most of the NoSQL stores nowadays are highly available. I mean, it's not like 100%, but at least you can achieve like 4 nines maybe, right? So we compromised on that. And then now talk about the scalable. Systems should be scalable because like we are very robust. No, we get the bursty traffic sometimes, right? We are very seasonal. So December Christmas period, February 14th Valentine's Day period, or whenever our marketing runs any campaign, we get more requests and more site traffic. So we have to make sure that we scale accordingly. Flexible schema, and we know the problem with the schema, rigid schema. We used to have 20 tables. It's a highly normalized schema. So we have to make sure that next store, whatever we choose, we have to carefully consider these schema requirements, because especially our product wants to support more message types, which means like more different types of messages. So finally, rich query support. So all our use cases requires more filters. Filters on your age, filters on like recent communication date, filters on whether read or unread, more counts. So we want to apply all these filters at the store level, not at application layer, because we don't want to get this JVM heap penalties. Okay, so that with that requirement, we went with MongoDB. So there is no other store which satisfies all these requirements. Okay, that's clear. Now the question is, should we build in-house on-prem, or should we choose a hosted solution? So that's the question is. Most of our services, 99%, all the services are deployed on-prem. So we have our data centers. Okay, but the problem is when this project already had a very tight deadline. We have to finish this project in 3 months. So when we have our first meeting with our operations team, we asked for like, hey, we want this hardware. We want to set up the MongoDB cluster. So they said like it's going to take a month or so. So to procure the hardware and the provision, and on top of it, like set up the MongoDB cluster, it's going to take time. And then we don't have any experts in-house, right? MongoDB experts. On top of it, since it's a very new system, very critical system, we have to spend some time fine-tuning the queries or whatnot. So it's very hard for us to set up in that short span of time. So we wanted to go with MongoDB Atlas. So why MongoDB Atlas? Easy to maintain. With few button clicks, you can set up your cluster in no time. So no need for on-site DBA. So maintenance is taken care by MongoDB guys. We don't worry about the patching. We don't worry about the upgrades or whatnot. Monitoring and alerting. Out of the box, they have the monitoring and alert. We have to do very few tweaks. Ilan is going to explain you that. We have to do very few tweaks to get going. And of course, you get the automated backup, disaster recovery, and high availability or whatnot. So with that, I mean, we are pretty sure that we want to go with MongoDB Atlas. So that's the complete architecture. Now we have everything. That's half of the problem solved. The rest of the half is like how we design the schema, how we fine-tune the queries. For every use case, we have to map that particular query and make sure that the performance is good. And we have to do the load testing and make sure that one of the important thing here is all of our services are within the same data center, but now we are going out of our data center to store the data, right? We don't have any dedicated connection. We are going over the open internet. So there is a latency concern. We have to see that. And also there is a security concern because we are not hosting it anymore. It's hosted somewhere else, like how we are going to maintain that security, right? So Ilan is going to talk about all the implementation details and our journey to the production. With that, I'm handing out to Ilan. Thank you.
Thank you, Vijay. Hi, everyone. I'm Ilan Srinivasan. The very first step in implementing the messaging platform is the schema design. This was a very important step because if we get this wrong, we'll end up with a system which is rigid, non-performant, and unable to meet our current and future needs. Coming from a relational database to a NoSQL database, we ran into some modeling challenges. We had to figure out how to deal with related information. Do we store it in a normalized way or a denormalized way? How do we deal with heterogeneous versus homogeneous sets of data? Having a good understanding of all the use cases and the kind of database operations we intend to perform for those helped us overcome these challenges. Users can send or receive a message, mark messages as read, and view read receipts for a message. All the actions are tied to a message, and a message can be modeled as a simple document with fields to track this information. This is a very simple schema design, and it would work great if you have all your data on a single Mongo node. You can have indexes on the sender and the receiver user ID and perform queries against those. However, we were building a new system with an unknown traffic pattern. We were looking at a database configuration which could scale with an increase in traffic. With Mongo, we were looking at a sharded configuration. With sharding, your queries need to be highly targeted. Every query needs to have a shard key in order to be performant. Looking at this model, between sender and the receiver user ID, there's no deterministic shard key. So this model wouldn't work for a sharded configuration. So in the next iteration, we took a different approach. On our system, compatible users are tied to each other by using a unique ID called as the match ID. A user could be associated with one or more match IDs. The messages are common to both the users, and so is the match ID. It made sense to tie all the messages to the match ID, a unique match ID, rather than tying them to two different user IDs. Following this approach, there were different ways to model the schema. The first approach that we were looking at was an array of messages kind of an approach. We have a single document with fields for the match ID and an array for the messages. So all the messages exchanged between a compatible users are stored in an array. It's a simple schema, logical grouping of the match ID and the messages, allows easy retrieval of chat history between two people. But there are some disadvantages here. If those users are highly conversant and exchanging a lot of messages between them, the number of items in the array would increase, which means your average document size would be higher, leading to a bigger memory footprint on Mongo. Also, queries when you're dealing with an array-based structure are a little more complex. And given that we have one document which is shared between two users, when they exchange messages, there are higher chances of document blocking. This being a real-time chat messaging system, it's very possible that we're going to run into document locking and latency issues. In order to overcome these challenges, in the next iteration, instead of storing all the messages in a single array, in a single document, we broke them up into individual documents. So every message is now a document by itself with its own unique message ID. And it still has fields for the match ID and other metadata. This is a much simpler schema, more memory efficient, and allows simpler queries. It also helps with faster writes, because every new message exchange is a single document that needs to be put into the collection. This is the final document model we have. We have two collections. The message collection handles the conversations, history, and count use cases. The user collection is used to track all the recently selected questions, template questions by an user. On the platform, users can send messages of different type. They can send a smile, they can send a open text, template questions, template answers, etc. We have leveraged a flexible schema model provided by MongoDB in order to support these different message types. We use one of the fields in the schema, the type field here, as a discriminator to differentiate between the different message types. Collection sharding. The message collection is sharded by the match ID, and the user collection is sharded by the user ID because that's very user-centric. Now let's look at the queries behind the features here. Users' conversations are rendered in a reverse chronological order with the most recent one at the top. The message collection is sharded by the match ID. So the conversation, the messages exchanged between a user and other users could be stored on different shards of Mongo. Given this is the query we use to leverage to retrieve the last exchange message between two compatible users. In order to render the conversation screen, we have the application layer reach out to Mongo in parallel with all the match IDs associated with the user, and then aggregate the result at the application layer and then render the conversation screen. In order to show the count of new messages received by an user, this is the query that we use. This aggregates the count of unread messages associated with an user across his matches. This is the query that we use for the chat history. The skip and limit functions are used to provide a paginated view of the chat history. Once we had a handle on the schema design and sharding, our next step was to evaluate the performance of the schema. Also, this was the first time we were using a cloud database as a service solution, and we had some concerns there. Every call from the application deployed in our data center to MongoDB Atlas has to traverse the internet. And we did not know what kind of a latency the multiple network hops would introduce. In order to figure that out, we did a simple benchmarking by setting up a data access layer as a service. We have an API for each database operation that we intend to execute on MongoDB Atlas. We subjected this service to a lot of load, and the results from the benchmark were satisfactory. We noticed that the presence of the internet and the multiple network hops did not introduce a lot of latency here, and the response times were still within our SLAs. The load testing not only helped us with the latency issue here, but it also helped us verify the impact of data growth and sharding on the query performance. Some of the best practices that we followed was not to create too many indexes, leverage compound indexes, and make sure our queries are covered queries wherever possible. And when it comes to update, in order to avoid a round trip between the application and the database, we used the atomic update or in-place updates feature provided by Mongo. The next step was to figure out the configuration. In order to figure out the configuration, we took our existing peak and non-peak messages exchanged on our existing guided communication platform, extrapolated that for a 2-year period. Then we did a benchmark by loading the messages collection with 300 million messages, and based on the stats that we collected from this test, we were mainly looking at the average document size, compression ratio, storage index, and stuff like that. Based on the stats that we collected here, this is the final configuration that we have for a Mongo prod cluster. A simple 2-sharded cluster with 3-member replica set, 32 gigs of RAM on each node, and 160 GB of storage. We started out with two replicas, 2 shards, but MongoDB Atlas being a scalable solution, with an increase in traffic during our peak times like Thanksgiving, Christmas, we can always scale out. Monitoring is again an important aspect of database administration, and MongoDB Atlas does an excellent job at it. It automatically tracks the various metrics at the system, network, and the database level, and it also provides visualization on top of those metrics. Here's a snapshot of the stats that we collected from our production cluster. We can clearly see that we are more of a read-heavy system than a write-heavy system. MongoDB Atlas also has integration with other third-party APIs like Slack and PagerDuty. At eHarmony, we have leveraged this integration to set up a multi-tiered alerting system. And some of the key metrics that we actively monitor and alert on are these. This is a graph or a report collected based on the data collected by our data analytics group. The new messaging platform was released at the end of December 2016. And looking at the graph, we can clearly see that the number of users in communication has increased since then. Also, the total communication volume on the system has increased since the release of the new chat feature. To summarize, following a simple approach of analysis, schema design, load testing, and then reiterating over the results helped us come up with a schema which is robust, efficient, flexible, able to support our current use cases and future ones. MongoDB Atlas has been an excellent choice for this project because it has helped our development team focus on the features and not be worried about things like database provisioning, management, monitoring, and stuff like that. With help of MongoDB Atlas, we were able to get this project done in the shortest amount of time, and we had a robust, worry-free deployment when we went to production. With this, I would like to hand over to Vijay.
Thanks, Ilan. So just to add, Ilan, like we deployed this solution within 2 months, and then we only worried about our development effort, not about the MongoDB provisioning or cluster setup or whatnot, right? So we have to do the bunch of like load tests to figure out the response times and also fine-tuning the queries. But I would say that that's what our job is as a developer, not like provisioning the MongoDB cluster and then setting up the monitoring and whatnot. I can fairly say like it's been 6 months or so. It's very stable with consistent response times, and user experience is awesome. So I would definitely recommend MongoDB Atlas. So there are a few more things. Now it's proven that like it can be a good store. So we wanted to bring in few more use cases. Obviously, we wanted to support more message types like videos, images, maps, locations, or whatnot. And also, we are looking for the presentation-ready feed. If you look back like few slides back, we are still aggregating at the API layer to present the conversation screen. So we get all the matches from a different store, which is HBase, and then we enrich that with recent messages from the MongoDB. But we wanted to create the presentation-ready feed to reduce further the response times. So we are considering the MongoDB Atlas for that as well. So with that, we are open for the questions. Thank you.
All right. Thank you. Thank you very much. Great presentation. Great presentation. So as I promised, we'll pause for questions. We've got about 10 minutes. Does anybody have a question that they did not put in the channel? All right. We'll start with questions in the channel then. So did you consider using Elasticsearch for persistence?
No.
No.
So,
all right.
Okay. Let me explain you why we did not consider. So, we are using MongoDB already with our product, with other product for our compatibility system. We have been using MongoDB for more than 3 years. It's great. So, and we have developers who knows MongoDB very well, right? So the expertise, and also like MongoDB is solving the problem, why we look for another solution and explore that.
Great. So what's the scale at which you are handling these messages in terms of writes per second, total collection counts, etc.?
Okay.
The total collection count, we right now have only 2 collections. The message, which is really a large collection. We probably like in a day we see like 100,000 messages exchanged between the user. In a month, we probably see like 1 million or 2 million messages exchanged. So it's growing consistently. The other collection user is mainly used to, it's very user-centric. It's used to track like what are the questions that a user has recently selected, like the top 5 questions that he has selected, things like that. So that's pretty much it.
Yeah. So and it's bursty during like evenings, and also like during the Christmas period or Valentine's Day, there will be more messages.
So how often do you go back and examine index utilization to ensure that you have continued optimal performance?
We have actually, the system is performing very well right now. Like I said, we have been using covered indexes, so we are at a good level. I mean, we are at a good state where we don't need new indexes or anything like that.
Yeah.
Okay. How are you going to store images and videos?
Yes, that's the plan.
Are you going to leverage MongoDB?
Yes.
So you'll use GridFS. Terrific. Okay. Have you found Atlas to be cost effective compared to on-premise?
That's a tricky question. So it goes both ways, right? The cost effective, yeah, maybe we might have some cost, right? I mean, on-prem always like less cost, but you have cost in terms of the human resources, right? Now I don't need to have a like on-site DBA, right? Or I don't need to worry about like all these patches and everything. So that's what I would say cost effective. But otherwise, like I mean, of course, as SaaS solutions, they come up with the bells and whistles, also with a little bit of cost.
Right. Are you considering analytics to determine geolocation, genders, success on matching?
Yeah, but that would be a different project. So we also have one more thing in the roadmap, just to let you guys know. It's called the recommendations. So today, we present certain template questions to the users, but they are all like randomly given to the user. But we wanted to leverage our recommendations team to customize or personalize the questions or whatnot based on the user preferences.
You said you didn't have in-house MongoDB expertise, so do you have to hire consultants from MongoDB to finish the project? So
Yes.
you did. Okay. Used a DCE?
Yeah. So Mark is right there. He's our consultant. He helped us really well. So I think like he came down for like 1 week or so. We went back and forth for the schema design and also query optimizations. But yeah.
Great. How did you overcome concerns regarding security and data privacy?
That's a good question. We didn't cover that one. But anyways, the security is one important aspect. So what we did was we whitelisted our IPs at the MongoDB Atlas, and it's a TLS. It's a secure communication. The whitelist will prevent that nobody can access our data except we accept the data. Is there anything else you're looking?
Well, so are you leveraging encrypted storage volumes?
Nope.
Okay.
We are not encrypting our data. It's encrypted over the wire, but in the store we are storing as plain JSON.
Okay. Gotcha. Okay, so we've reached the end of the questions in the channel. Anyone have a question in the room? Terrific. Well, thank you very much. Oh, one more question. Okay, here we go.
I'm just curious, how big was your development team?
I'm sorry.
How big was your development team? You said that you completed the project in 3 months.
Okay, so that's a good question. So our development team is about like 25 or so. Basically, we go by the features team because it's a microservices architecture. Each vertical has its own team, or we try to fix we try to fit like 2 or 3 features into one team, right? This project, I think we deployed 4 developers, and like few QA and a few operation DevOps guys.
Yeah, I think there were just 4 developers on the backend supporting the entire architecture that Vijay showed. So
yeah, let me correct on that, right? 4 backend developers for the MongoDB, like maintaining the APIs and whatnot. We have another beast, which is like eJabberD. That's again XMPP, like a WebSocket-based system. So that caters all 4 clients, like Android. We have Android team, iOS team, mobile web and desktop team. I'm not talking about them. It's just like purely server side.